Okay, everybody. So this is the last, I believe, last section. Do we have one more? Oh, yeah, we have one more past this. Recursive. So almost the last one. So geometric sequences. So you might be saying, this is Bassett. I remember doing arithmetic. Right, because arithmetic sequences was a common difference, right? So do you remember, let's see, a sub n was a sub 1 plus d times n minus 1, or n minus 1 times d. This was arithmetic. Okay, this was modeling linear. Okay, now we're doing geometric. Well, why are we doing geometric? Because it's a multiplier. And what have we been doing with exponentials? You're right. We've been multiplying them. So our first identification is deciding whether this is geometric. Is it arithmetic? Or is it neither? Now, this should not come as something new, because you know what, friends? We have been doing this with x's and y's, right? So we would have, so remember, our x and y here would be our terms, remember? Term 1, term 2, term 3, term 4. Remember that? All right, so 120 to 60. Well, I could do a minus 60, right? So maybe I'm subtracting. Well, 60 minus 6, oh, that's not 30. Okay, so I can cross out, it's not arithmetic. Okay, what about a multiplier? Let's see. How about a half? Half of 120 is 60. Half of 60 is 30. Half of 30 is 15. Yes, I found it. So this is a geometric sequence, okay? And take it one step farther. If I'm multiplying by half, friends, is it exponential growth or decay? Oh, it's less than 1. It's decay. You guys are so good. All right, how about this one? 2, 6, 11, 17. All right, remember, this is term 1, 2, 3, 4. So I'm looking at these. Well, let's see. If this was times 3, does that work here? No. All right. Difference between these is plus 4. How about this? That was only a plus 3. And that's a plus 6. Oh. I don't think it's either one. This isn't a constant number. Oh, so this is neither. So I can't think of an addition number, and I can't think of a multiplier, so that doesn't work. Okay, questions on that? Okay, so extending a geometric sequence. So here we go. So 3, 6, 12, 24. So I'm going to put a line here. Okay, so keep going. This is to extend, please. So keep going. Come up with the next 3 terms of the sequence. Are you ready? What's going on here? It's geometric, okay? So that means it's a multiplier. So 3 times, you're right, 2, 6 times 2, 12 times 2. 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 96 plus 96, 2. Carry the 1 is at 192. Better check. Yep. So there's our 3 answers. All right. Your turn. Are you ready? I'm going to give you this one. This one might be This one might be a little tricky. What? Negatives? Okay, try to figure it out. What's the pattern? 80 times what gives you a negative 40? You guessed it? Well, I know that half of 80 is 40. So if I take a half, so if I want it to be negative, I need to multiply by a negative 1/2. But is a negative 40 times a negative 1/2 a positive? Oh, yeah. So this is how it's going to alternate positive, negative, positive. All right. Negative 1/2. Negative 1/2 times. So this would be a positive 5 times a negative 1/2 makes negative 5/2 or 2.5. And times a negative is positive 5/4. Or this would be negative 2.5 and this would be negative 1.25 or positive 1.25. Sorry about that. Okay. After that, we're looking at being able to write the geometric sequence. Are you ready? So here is as a function. Okay, here's the equation. A sub n equals the first term of the sequence times your multiplier to the n minus 1 power. Okay, I'm going to block this in. Make this super, super special. Okay, we got this. Okay, so here we go. Write an equation where this is the sequence 2, 12, 72, 432, ... And then when we're done, we're going to find a 10. Okay, so the first thing we need to do is we need to identify what is our common, what's our R, what's our, we did it with D for difference. What's our common multiplier here? So 2 times what is 12? 6. 12 times 6 is 72. 72 times 6 is 432. Okay, so 6 is going to be our R, our multiplier, okay? And then we're looking for the other piece is what's our first term of the sequence? Well, that's easy. It's the first one given. Okay, so here we go. A sub n equals 2. I want you to put times, like a dot, 6 to the n minus 1 power. Okay, now, I do not, did you get that? Do not take 2 times 6. According to the order of operations, what would you have to do first? You would have to do the exponent. So do not make that, do not touch that. Remember how we talked about a 2 will make something steeper? You leave that just like it is, okay? Now, if I want to find the 10th term, here's what I do. I take my equation, okay, and I plug my 10 in for my n up in the top, okay, right there, see? All right, then on my handy dandy calculator, okay, on my handy dandy calculator, everybody see that okay? All right, I'm going to put I-10, you can put it in like this if you want, 2 times 6 to the, and I put everything in parentheses. Now, I know that 10 minus 1 is 9, so I'm just going to put 6 to the 9th. So 2 times 6 to the 9th. Wow, that's going to be a really big number. A sub n is 2015539. Go back, put your commas in. Ooh, 20,155,392. Okay. See? That wasn't so bad, was it? All right, you try this one. 4, 10, 25, 62.5. 4 times what is 10? Now, if I can't really think, I know 4 times 2 is 8. Could I go like this? Could I go 10 divided by 4? Oh, 2.5. Okay. Could I then try 25 divided by 10 to see if I get the same thing? Oh, yeah. What is that big number? 62.5 divided by 25? Oh, 2.5. Okay. So 2.5 is my multiplier. Okay. What's my first term of the sequence? It's a 4. Okay, well, almost, pretty much almost done here. A sub n equals 4 times 2.5 to the n minus 1. Backs are in. And then it wants me to find in my directions, I have find a sub 7. All right, put a 7 in for the n. So a sub n equals 4 times 2.5 to the 7 minus 1 power. Okay, notice on my calculator what I'm doing. I'm going to put 4 times 2.5 to the, now 7 minus 1 is 6. So I'm just going to do it. When I put it on the calculator will do the exponent first and then multiply by 4. And I get 976 point. I'm going to do 2 decimal places. So to the hundredths, so I'm going to go one more. 2 is 4 and below, leave it low. So 5, 6. Questions on that, my friends? All right. That's it. That's all. Thanks a lot, friends. Bye.